we're still in the steam engine era of AI, right? Building these kind of nuclear powered data centers. It's not sustainable.
Doing AI on the edge, and then all of a sudden they came to us and said, okay, we got to move it all out there. Their AWS bill was through the roof.
The AI innovation cycle is outpacing the product development cycle.
If we don't have all the technologies today to build these devices, we will in the next year or two. In 2026, there's no place more exciting to be than building ultra low power processors for the edge for AI. So suddenly the electronics have become a appreciable portion of the overall energy budget. The processor stack running all the AI was actually consuming more energy than the motors themselves. The AI will certainly be everywhere. I'm in the picks and shovels business. I'm giving them eyes and ears so that they can see what's going on in the real world.
Efficiency is the new currency. That's what they say. So.
You got it.
Welcome to the Edge of Tomorrow, the Edge AI Debate, a spin-off series of the IoT Podcast brought to you in collaboration with the Edge AI Foundation. We're bringing together some of the brightest minds in Edge AI and beyond for discussions on the most pressing challenges and opportunities shaping the future of AI at the edge. This isn't just another AI podcast. Every episode cuts to the core of the technology we're building and the path we're on, offering diverse perspectives and hard-hitting analysis, and the kind of conversations that leave you questioning everything you thought you knew about Edge AI. This episode is brought to you by the Edge AI Foundation, a global community of innovators, researchers, and industry leaders working to make Edge AI more accessible, sustainable, and impactful for the real world. At Edge AI Foundation, we believe the future of AI isn't just in the cloud, it's at the edge. We're focused on building and scaling intelligence where it matters most, in the devices, sensors, and systems powering our everyday lives. Now, let's dive into the show. Welcome, everybody, to the Edge of Tomorrow. I'm here with Scott Hanson from Ambiq, and we're going to spend a chunk of time talking about Edge AI, as usual, for me at least, and probably for Scott as well. I know he mentioned he talks to investors. Half the time he talks to folks about this stuff. So I think we're both pretty well practiced in this topic, but I think we will learn some new things today about Ambiq specifically and get a better sense of what's actually happening in the space, the AI space that I consider to be the most important part of AI, which is happening where the data is created in the real world, where there's real impact and all that good stuff. So Scott, welcome to the podcast.
Thank you. I appreciate you having me.
Are you in Austin right now?
Yeah, in Austin, we're right at the front edge of summer here, so it's getting warm.
Ooh, nice. Yeah, I'm here in Bellevue, Washington, and it is raining, but that's not too surprising.
Right.
So it's getting a little warm in Austin. It's raining in Bellevue, so everything is normal. No problem.
The world is right, yeah.
But yeah, so before we get into kind of the nitty gritty, give us a little bit of a backstory, maybe origin story on Ambiq. And, you're a publicly traded company, but I think you're originally a Michigander, right?
Yeah. So Ambiq was founded out of my PhD research at University of Michigan. We were building little cubic millimeter computers that would be used in the battlefield, used in medical implants. So we had these little cubic millimeter devices that would have a battery, a processor, sensor, radio, everything. And then you'd implant it in someone's eye in a glaucoma patient or some other patient type. So really cool, really cutting edge stuff. Got to the point where a number of companies said, hey, I'd love to see this commercialized. And we thought we were going to be a medical device company at first, right? But there's one thing you learn is that takes forever to start a company. And there's only one type of company that's like marginally faster than that, and that's to build a chip company. And so that's what we did. Is we built a microprocessor company. Ambiq today builds the world's most energy efficient chips. The vision would be that everything from a 50-cent processor to a $50 processor and the whole spectrum in between is what we deliver. And the point is, as AI has broken out of the data center, we've got a ton of compute needs out at the edge, out in battery constrained devices, and Ambiq delivers that. So it's been a fun journey. We've got a really cool technology that I can talk more about if interesting. But in 2026, there's no place more exciting to be than building ultra low power processors for the edge for AI. So exciting times.
For sure. So how big is Ambiq these days?
Oh, we're roughly 220 people. We've shipped in excess of 300 million units over the years. So, I'm wearing a couple of our customers' products right now. So all kinds of wearable devices, all kinds of industrial electronics, medical devices, smart home devices. The other metric on size is just like we just reported our Q1 earnings and quarterly revenue was at about 25 million. So company's
Nice.
growing really healthily, and we've got a nice outlook for the rest of the year. So I'd say that we spent a number of years really trying to figure out what the technology was going to look like. Building a chip company is really hard.
Yeah.
The cost of mistakes is really high, and so you have to
Mm.
move a bit slower than software companies. But as we were developing our core competency in low power, this IoT thing was kind of emerging, and then that morphed into what is now Edge AI, and here we are today. I think the timing is perfect.
Yeah. Yeah. No, it's a good point you make about chip companies, hardware companies. I mean, I worked at Microsoft, software company, although we built a lot of hardware too. And I actually worked in different groups there. And it was interesting to see the culture of the different groups and how they worked in terms of attention to detail, right? So working in the hardware team, you got to get it right. So software
Absolutely.
team, push it out there,
Well, my software team will get mad about with me saying this, but here's the consequence of having a bad software or a bug in software is that you recompile and you spin it
yeah,
and deliver a new product. In chips, a recompile means I've got to
no,
tape out a whole new mask set.
right,
It costs me millions of dollars, and
right.
there's a multi-month delay. So it's a different mindset for sure. And actually, one of the things when I first founded the company, I made certain that I had far more experienced people than me building these chips. Right? I was
Mm.
how old was I? I was in my mid-20s starting this company. I had a PhD, but no real work experience, and so it was really important that I found people who had been building chips for a career. And we did that at first, and then over time we started bringing in more junior engineers. But it was really important to have some smart people, experienced people along for the
Yeah.
ride.
Yeah. No, you're right. I mean, yeah. And people that really know the operations and the timescales and
Yeah.
the equipment and, the testing and the validation. I mean, all that stuff comes after the great ideas, in terms of executing them. So that's, pretty critical stuff. I guess one of the questions we can start out with here, and we're going to talk a little bit about kind of where this Edge AI vision is heading. And maybe we can even do a little 100 level Edge AI for those that are not as embedded in it as we are. And then we'll talk about the vision. Then we're going to talk a little bit about sort of where the action is today. You mentioned you're shipping a lot of units. So there's a lot of stuff going on out there. And then, one of the interesting things will be sort of, we hear a lot about agentic AI and physical AI and generative AI and analog AI and neuromorphic AI and embodied AI. So it's like every day there's another thing. So we'll talk about that as well. But let me scroll back a little bit to your product statement about development. I guess the question is, what I find is that this edge AI space is moving so quickly. I was actually talking to someone from Google this morning, and we were just like trying to top each other on the newest thing that's happening. And it's like every week there's a new thing. As we're talking about like making chips or making hardware, I mean, it's a long development cycle. It feels like the AI innovation cycle is outpacing the product development cycle a little bit. Yeah. And it's hard to sort of like almost reconcile the pace of innovation with what it just takes to make and ship a product. Yeah. I mean, how do you guys think about that?
Well, a couple of ways to answer that. So first of all, the chip team moves at a certain pace, right? And offers products, but we have a software team. In fact, on any given day, there's more people writing software at Ambiq than building hardware, right? There's our software team, there's our AI team, which is really a software team. There's our field applications team, which is really mostly software engineers helping our customers. And the development cycle on that software is a lot quicker than the hardware, right? So that's part of how we keep pace. But part of it too is that we're aiming ahead of where our customers need to be. They tell us where they need to be this year and next year and 5 years, or maybe fuzzy idea of 3 to 5 years from now what they need.
Sure.
And so we're attempting to kind of lead the receiver, so to speak, on that and have more than they need. And there's one thing we know is that software engineers and AI engineers will always fill however many cycles you've got available, however much memory you got available. They're gonna fill that up. The other thing I'll say is I'm a big fan of general purpose architecture. So what I mean by that is, you talked about neuromorphic earlier. You mentioned neuromorphic earlier. There's a lot of specialized AI acceleration techniques that require custom hardware or custom network structures. I really want to avoid all that. I want to build a general purpose machine that is capable of running multiply accumulate operations hyper efficiently. And what's cool about our particular platform at Ambiq, we have this core platform we call Spot, subthreshold power optimized technology. And without giving you a whole like circuits 101 lesson here, we're running transistors at extremely low voltage to get huge energy savings. And that transistor doesn't care if it's running a general purpose CPU, an NPU, a DSP, baseband processor for a radio. And so, in that way, what I can build is I can build a great NPU or a great vector accelerator that just runs any network style that I want. So in that way, we can keep pace a little bit with what's going on out there.
But don't you think that things, I mean, in the long arc of computing history, like processors do get more specific, right? I mean, we go from CPUs to GPUs to NPUs.
They do. And, if you look at what our processors have gone through, the first processor that we built, it was called Apollo, and it had a microcontroller core, ARM Cortex-M class core that could run at 24 megahertz, and it had a few peripherals. And it's kind of laughably simple now that I look back at it. That's only, 12 years ago, right? Our latest chip, the one that we're actually taping out this year and launching formally next year, is called Atomic. And it has a GPU, a CPU, it has an NPU, it has a DRAM in package, it has all kinds of other, computing cores, a cryptographic accelerator on board. So we've become quite a bit more specialized. So, one side of my mouth, I can say, yeah, let's keep it general, but there's some, specificity needed.
Well, sure. I mean, even at the mighty NVIDIA and Jensen Huang, who's never wrong about anything, was all into GPUs for a while. And then they bought Grok because they realized that, doing sort of language acceleration was kind of a bit of a different beast, so sure. It feels like, everything is as general as possible until it needs to be more specific. Right. And then I guess that's so, in defense of the neuromorphs, sometimes when you have very specialized, applications, right, that, really require orders of magnitude more power efficiency. And it's not really an open and generic platform. Maybe there's room for some more specific innovation for those specific applications. I don't know. But
hey, I believe it. Yeah, no doubt.
Hey,
one thing I will say though is I never bet against Moore's law. So I know that, on the very bleeding edge, Moore's law is slowing down, and everyone's always wondering, hey, are we going sub 2 nanometer? Are we going to go sub 1 nanometer? But, the edge is living a couple generations back from that, right? We started at 180 nanometers. Our newest products are in 12 nanometers, and there's so far to go from there. And so, my point is that the kind of conventional digital processor is just going to get better and better and better. And cost per transistor, performance per transistor, power per transistor is all improving. So,
true. And, the software architectures are getting more efficient too, right? Like vector symbolic architecture, VSA, things like that. People are really like rethinking. I like to use the term that I think we're still in the steam engine era of AI, right? We're still sort of brute forcing it. Yeah. There's going to be some re-architectures that happen that give us multiple order of magnitude efficiencies, because current course and speed, and I know we're kind of edge folks, so we don't really bother with data centers, but the idea of building these kind of nuclear powered data centers that kind of suck up the water table to do this stuff, it's not sustainable. It's not, there's an asymptote there, and maybe we hit the asymptote. I'm not sure. But there's got to be, more than just kind of the brute force compute that's currently happening. It's like, well, just build a 5 football field data center. It's like, well, that doesn't really sound like the right way to go. But
we talk publicly about our hardware having a 2 to 5x power advantage compared to conventional approaches, and I would say in practice it's often 5 to 10x power advantage. When I'm telling the software teams, the AI software team and our other software developers, is find a way to give us another 5 to 10x power advantage, right? Combine all that together and give us a huge advantage. And I think it's there. We get with customers, and they'll show us their network architecture that's running on this in some obfuscated way, or anonymized way, and there's almost always some way to dramatically speed things up, reshape this layer, or we'll write a custom kernel for this other layer here, or hey, this particular layer is not mapping efficiently to hardware, and we'll approach it in some other way. So there are almost always ways to dramatically improve the execution at the software level as well.
Mm-hmm. Yeah, for sure. For sure. So you mentioned about kind of shipping some stuff. Like if we talk about the reality of the scale that's happening right now, you talk about hundreds of millions, and that's Ambiq, and you can throw in, within the foundation, we have about 70 different companies doing stuff. And that's probably just a portion of the ecosystem. So, I mean, it's really starting to scale out there. What do you see that's really triggering a lot of the drive for scale these days? Like, and what are still points of friction?
Well, what's driving scale? What I'll start by saying is we saw edge AI deployments going back to 2016, 2017 on our products, right? We've got various generations of our Apollo processors. In the last 10 years, the majority of the units have been used in wearable devices, which have morphed into more health tracking devices that have a cloud-based agent that's monitoring everything you do and giving you advice. We saw the first use of AI there, and they've just only gotten more sophisticated, right? They have built systems now that might have in excess of 5 AI models running on your device simultaneously. And they have ambitions of going really, really far into the future. But what's notable to me is that in the last couple of years, we've seen basically every other customer we have is talking about it or deploying AI. Just in our last few earnings calls, we've disclosed that in excess of 80% of our units shipped are running some kind of AI model, and that's exciting, right? And it's not just the wearables; they are certainly the most aggressive and earliest users, but we're seeing everything from water leak detectors and smart home deployments to machine health monitors. That's probably one of my favorites, is the machine health monitor that's doing anomaly detection. Right, you got a Coke can size sensor that's monitoring vibrations and sound and whatever, and is looking for changes in that and says, "Hey, I just saw a change in vibration. Better come out and fix me. I think I might be failing soon." So that's a cool use case. All kinds of medical devices that are looking for falls, somebody falling, looking at heart health. And so, yeah, a lot of really interesting deployments that are starting to happen. And, you asked about points of friction. On my side, the point of friction is just there's so many diverse use cases that the AI team can't possibly keep up with it. And so what we're focusing on is the class of problems that we can uniquely solve. Specifically, we like to say that we're giving our customers picks and shovels so that they can go mine gold, right? I'm not going to be in the gold mining business. I'm in the picks and shovels business. So I'm going to give you the best kernels out there. We're going to give you compilers and runtimes that are hyper efficient. We're going to give you what we call AI development kits, which is maybe includes some example AI models that we've pre-trained, but has a lot of the other building blocks that you need to get going and build your own model. So what we're seeing is a lot of the chip vendors out there are trying to get you to play in their proprietary sandbox, right? They build some beautiful service where you it's auto ML, you push a button and out comes a model, right? And I think for a certain set of customers, that's a wonderful solution. But we're finding that real AI engineers, real data scientists, real model developers, they want to use the flows that they're familiar with. And so we want to give them kind of a modular system where we're giving them picks and shovels. We say, use them as you see fit, slot them into your flow and get going.
Yeah, I think if companies are building something really unique, they need to sort of invest pretty much down to the metal if they're really going to do stuff. There's always going to be folks that, yeah, sure, take some stuff and put a logo on it and ship it, but that's usually not pretty cutting edge. Actually, speaking of interesting, I'm going to ask you about your favorite deployments, but actually just as a little anecdote, I bought this thing called a droplet the other day. So I have this house in Massachusetts, and it's a pretty simple thing. It's like just a little clamp. It clamps onto your water main, and basically based on vibration sensing, right? It'll detect water flow through your house. Yeah. And then, you say how many faucets, or have an outdoor shower there and a lot of other stuff. And then you just go around and you flush the toilet and you watch the meter thing. You tag that activity as toilet, or outdoor shower. Okay, that's the outdoor shower. And then, so I did that and, walked around the property and did that. And then now I get remotely. So I just flew back last night from Boston. So now I can see who's using what in my house from a water flow, just for like just the vibration patterns of the water main are detected, and
Incredible.
basically
Incredible. And you know what's exciting is that next level up where you're probably in the loop of that, but it could just as easily go to an agent, a cloud-based agent that's sitting there and looking at it and kind of telling you a story at the end of the day of, hey, it looks like pretty normal water usage today, or hey, I noticed that there was some extraneous water usage. Let's get somebody out there. Or I ordered a repair person to come out and take care of that.
No, I mean, if I assume that if these guys have like an MCP server or something, and I use this other app called Little Bird, which is like a Mac OS, Little Bird. So, and I have that connected to a bunch of MCP servers. And so every morning I get my daily briefing and I get all my MCP data kind of, with the natural language, like, hey, here's what's going on. So definitely Little Bird could say, hey, here's what's going on with your house in Massachusetts. And not only the water, but, the energy and the electricity and the heat and, take the ring cam footage and be like, blah, blah, blah. And so we're getting there. So I can definitely see like these days, I mean, these are all consumer applications, but I guess to your question, to kind of your business, are you seeing the volume more in the consumer space with like kind of the wearables like you're talking about, or are you seeing more in the commercial space, or how's it sort of translating?
Well, we certainly saw the first deployments in the consumer space, in the consumer wearable space. Yeah. And right now, I would say the most aggressive roadmaps are coming from that space as well. And I'll specifically call out anything body worn. So whether it's a watch or a band like this Whoop band I'm wearing, or smart glasses, probably the most aggressive roadmaps we're seeing. Yeah, there you go. The most aggressive roadmaps I'm seeing are in the smart glass space, because the minute you add a camera, you can do some really exciting things, right? So. Of course I can have cool UI with gestures and all sorts of other things.
Sure.
But for me, it's more about, I can tell who I was talking to with the microphone. We can, listen to what we're talking about. I can give me summaries, build action item lists, and kind of so the VC, Josh Wolf recently talked about so-called life recording as his next big thing, life recording. Right. And I love it. I do think that all wearables are moving toward that, right? And they're all doing it in their own unique way. Some of them are coming at it from a purely health standpoint. Some of it coming from I'm a smartwatch vendor, but all of them are converging on this life cording concept of we're gonna keep track of the context of your life. It's going to be health data. It's going to be who you're talking to, what you're talking about, what is going on with your family, et cetera. And we could get into a whole side conversation about the ethical implications of all that, but I, for one, am excited about what we can do there.
Yeah, no, I think it's definitely possible. And, just like when I use Little Bird, it accesses my emails and accesses my, my Google Meets. And so it knows kind of what I was talking about and all that stuff. So you get a little taste of that. I do agree that, like, especially getting into the kind of the wearables, hearables, implantables space, then there's some societal norms that are going to have to bend a little bit, in terms of recording. Like even my phone, like I could plop it down. I meet people at the coffee shop here, a place called Soul Food Coffee House. If you're ever in Bellevue, happy to take you there.
Okay.
And, always have my meetings there, try to get out once a day. And I can plop my phone down there and it can record the conversation just like a Google Meet, and it can give me the summary, but it's a little bit odd. It's like, I'm recording this conversation, So like at some point we will, as a society, just sort of default that everybody is kind of recording everything that's going on. And, that's always been sort of a hot button issue. I mean, we still have people that don't like the, automatic checkout at the supermarket. So,
sure.
There's issues with that. So this is going to be, that's probably it's not a technical hurdle there as much as the life recording will be more of probably a societal thing, unless it's like your personal recording, which I do. I record all my vitals and all my stuff. But once you start recording in public and who you're interacting with and stuff, I don't know. I know the EU will pass some legislation that says you have to have a big red light on in the center of your glasses or something.
And what's from a technological standpoint, we're basically there, or at least from my perspective, if we don't have all the technologies today to build these devices, we will in the next year or two. And so I feel good that at least the technology side of it is done. It's all that other stuff. It's the societal embrace of this stuff. Yeah. It's what government regulations are going to come down on top of it. And frankly, I do think some of that needs to be there, right?
Yeah.
These are dangerous technologies if deployed incorrectly. And
Surreptitiously.
companies. I know this well as a now publicly traded company. Our obligation is to deliver returns for our shareholders, right?
Mm.
And as a founder, I feel obligated to be ethical and lawful about everything that we do. But sometimes there's a need for outside bodies to regulate these things and make sure that
A
we're
little
doing
bit,
things that are
some
right for
guardrails.
everybody, right?
Well, funny, not a funny story, but interesting anecdote. When camera phones were first introduced, they were actually invented by Philippe Kahn from Borland. You remember Turbo Pascal? But he invented the camera phone. Long story. In Japan, caught on first, right? Maybe everyone was taking pictures of their food like 20 years ago, and we all thought that was kind of crazy. And we all do that. But the Japanese government introduced legislation that you had to make a camera sound, a little click, click or whatever. That sound had to be played whenever you took a picture with a camera phone. Mm-hmm. And that was enforced by Docomo and their handsets and stuff like that.
Oh, interesting.
And that was just so that you couldn't take pictures surreptitiously. Right. Which, obviously you can imagine some bad situations there. Yeah, so that was like an early thing where it's like, hey, you need to let people know I'm taking a picture because you hear that little sound. So I wonder, as we sort of get into this life courting thing, what we'll have to do there to, hold up a little sign. I am recording. Walk around. But I'm sure we'll see that in the Bay Area anytime soon. So you got a lot of cool things being deployed. So I guess one of the questions would be, so what happens next? Like we've talked about we've got these hearables, wearables, implantables, the buzzwords, I think we were talking about before we hit the record button, obviously there's agentic AI and there's, generative AI and language models and embodied AI and analog AI and physical AI, of course. And like, how do you see the evolution of, let's say, call it machine learning that's running right now in some of these embedded wearable systems to something more profound? Like, where does that start fit in?
Let me start by saying agentic AI is the vision in the sense that there will be agents that are managing the collection of all kinds of data and deciding what's relevant and making decisions based on that. And there will be an illusion that agent lives in these devices on our bodies, in the devices in our building, in our homes, and in our factory floors. And it's not as important where the agent actually does reside because we have connectivity everywhere now, right? So it takes almost no time.
Well, we sort of have connectivity everywhere. I mean, not exactly.
Not everywhere. Okay, but I think that what we'll see is that there are cases where it's necessary to have that agent on the edge. But I think for the most part, what you're going to find is a system similar to what actually a lot of our customers have today. So both Whoop and Garmin have this. If you look at all the leading wearables vendors at Aura or Google or whoever, they've got wearables that are collecting data, collecting all kinds of vitals, and that wearable is deciding what's interesting, right? They're identifying arrhythmias, the wearables identifying that I went to a CrossFit class at noon today, and then it's sending that macro data, let's say, up to the cloud, and there is an agent or there is an LLM with an agent wrapped around it, taking in all this data and asking questions. I've actually noticed that my devices have started asking me questions. Hey, I've noticed that you've consistently got a workout happening at noon. What are you going for? And if I say, oh, I'm training for a marathon in October, it's going to go, okay, here's a marathon training plan that I think you can use, right? This is happening. And what was interesting to me is I went to a smart home conference a couple of weeks ago, and they were having all the same discussions in that space about agent plus LLM in the cloud, monitoring your whole smart home. You've got this collection of heterogeneous devices that are all feeding data. It's your smart door lock. It's your security sensors all over the home. It's your thermostat and your smoke alarms and your smart fridge and everything, delivering data up to the cloud and then getting a home level view of what's going on. It's everything from what's the health of the people in your home to how secure is your home, et cetera. So I think we're converging on agents being and LLMs being present everywhere. Agents and LLMs in the cloud, they can't see or hear, right? They need senses. And so the people, vendors out at the edge like us are making that happen. I'm giving giving them eyes and ears so that they can see what's going on in the real world. So
Mm.
it's almost less important to me where that stuff, where the agent resides. It's more
Mm.
important to me is what is the system high level architecture. And one thing I know for certain is that those edge devices, they are running AI, because you can't just take tons and tons of raw data and send it all to
No.
the cloud.
Right.
Speaking of your connectivity problem earlier,
Mm.
I certainly can't, jam a camera, a multi-camera feed, multi-microphone feed, biosignal feed, all up to a cloud, and then have that be true for millions and millions of users.
No.
So
Yeah, I agree.
AI will certainly be everywhere, and then that we could sit here and debate about, where do the LLMs lie? Do they become SLMs that are at the edge, or is there an agent somewhere along the way?
Yeah, I mean, it's interesting you mentioned that, because like we started every 6 months, we do a kind of multi-day generative edge AI live stream. It's like 10 to 15 talks, tech talks, just back to back. A lot of academia, a lot of engineering folks. We've done that. We just had our 6th one, I think. And so we've been doing it for a few years, and it's really interesting to see the evolution of what is state of the art in generative edge AI, basically every 6 months, for a few years.
Sure.
And, I mean, as you know, running multi-billion parameter SLMs on a phone or an edge device, it's not that big of a deal anymore. Like, it's very de rigueur. And so, whereas, a couple of years ago, it was like, oh my God, can you actually run a really slow chat bot on a Raspberry Pi? So we've come a long way, even in that period, going back to our Moore's Law conversation. So I definitely think there's a gravitational pull that will move these things as close to where the data is created as possible. And I wouldn't be surprised to see sensors that have their own MCP servers in them, or MCP interfaces that could be queried by agents that could be running. That agent could be running on your glasses, or could be running on your phone. And maybe as a last resort, it gets to the cloud. I mean, one of the things that we've seen too is that, running tokens on the clouds can kind of add up. So a lot of these companies that are like, we're going to have AI for this and AI for that, all of a sudden their cost of good, their margin goes to like zero, because they're just, writing huge checks to Microsoft and Amazon. So it's like, well,
funny.
How do you move it out?
We spent a lot of years pitching the value of edge AI, right? And its latency, and there's power benefits and all sorts of things. But yeah, the cost one actually came to the forefront recently. We had a customer who was resistant to doing AI on the edge, and then all of a sudden they came to us and said, "Okay, we got to move it all out there." And we said, "Well, what changed?" And it was exactly that.
They got the bill.
Their AWS bill was through the roof. Yeah, and I get it too, right? It's amazing how quickly those AWS bills start adding up.
Yeah, no, it's interesting. And AWS is one of our strategic partners, by the way. So shout out to AWS. Love those guys.
It's a wonderful service. Hey,
wonderful.
Very important.
But yes, the OpEx can really start to add up. And, you always tell people, like, your AI project always starts in the cloud. And then, it gets optimized and commercialized and migrated to kind of a lowest cost, operational cost to make money on it. And that's when it tends to kind of jump the data center into the real world. But yeah, I think, getting these language models and agentic AI running in edge equipment is, kind of happening. I mean, we have a lot of interest in physical AI. I was curious, like Ambiq, how have you been involved in the physical AI space? You have humanoid robots walking around there, or what's going on?
Yeah, they're all walking around just outside my door.
Just outside.
It's a really important market that we see as a midterm opportunity, and there's two pieces of it that are really interesting. So, you break down these humanoid robots, and there are tens of motors that have to run, and all those motors need motor control, and the more complex the control, the more complex the algorithm, the more need for compute. And I've seen a lot of academic work talking about the use of AI, the use of AI models to assist in motor control. So that's one really important place. But then the sensing too, and there's centralized sensing where you've got cameras, but then there's distributed sensing where we've got pressure sensors and all sorts of other things. And Ambiq can play a role in all that, and will play a role. And the way we're getting there is that we're starting with mastery of devices like these and smart home devices and certain industrial devices, and all of the AI software and AI hardware that we've developed there are transferable to the humanoid and broadly physical AI opportunities. I think it's going to take some time, frankly, for that market to fully emerge. Right? There's a lot of big technical problems that need to be solved. Energy, by the way, being a huge one of them. Early on in Ambiq's history, we consciously avoided places like drones, and not because it wasn't a good use of our technology, but the motors were such a dominant source of energy usage in these
Hmm.
systems that it was like, we got to solve this problem, right?
That's right.
But then, if you look at the latest DJI drones, these things are ultra complex, right? They've got these super complex sensory systems that can do, all sorts of interesting things, and so suddenly the electronics um, have become a appreciable portion of the overall energy budget. In fact,
Hmm.
I know some people who were founding a garbage collecting robot company, and I was talking to them about where the energy was used in their system, and even for something as big as a garbage collection robot that's wandering around parks and picking up and compressing garbage, the processor stack that's running all the AI was actually consuming more energy than the motors themselves. So
Yeah.
that I thought was pretty remarkable, and
Yeah.
represents a really big opportunity for Ambiq. So
Yeah.
we will be there. It's just a matter of time.
Okay. Yeah. I think it's like physical AI. That's kind of the untold story right now, is the energy consumption and the battery usage. And, you can't just, and again, love NVIDIA, but, throwing a Jetson everywhere and, seeing what happens. Like, it'll run for like 20 minutes. So yeah, I think that's, huge in terms of bringing power efficiency to physical AI. We have a company that does actually specific, like, solutions for drone motor control and optimizing that. And they claim to get like a 50% improvement in flight time just by optimizing the motors for the drones,
No kidding.
using
Wow.
AI. So yeah, there's a lot of opportunity there. And last thing you want is a humanoid robot with a dead battery just kind of sitting there on the sidewalk. And it's like, that's a recipe for disaster.
Absolutely.
I was going to, before we run out of time, we still have some time, but I know in a previous conversation, we had talked a lot about career development. And, one of the things that we're invested in as an educational nonprofit and our scholarship fund is career development, because at the end of the day, you need smart folks to come in and build this stuff, like you said. And so what is Ambiq been involved in career development and university engagement? And you mentioned, Michigan and stuff like that, but is that part of your thing, or is there an Ambiq thing on that? Or how do you guys approach career development and sort of investing in the next generation?
Well, first I'll say, as a newly public company, it's something we're figuring out as we speak, which is exactly why you and I are talking, right? When I first built the company, and I think this is true for every entrepreneur, you're worried about next week. Will we live to next week or next month or next quarter, whatever it is? And so it's hard to think too much about the future. And the one thing I wish I could go back and tell myself 10 years ago is, hey, the company's going to be here in 10 years, so plan accordingly, right? That means invest in young engineers, bring them up, teach them what they need to know. And we're doing that now, right? Because we will be here 10 years from now, and 20 years from now, and 30 years from now. So back to your question, yeah, we're engaged with a couple different universities, both here and elsewhere. So in Singapore, for example, we've recruited a number of people out of the local universities there.
Cool.
We have an office there. We've got headquarters here in Austin, Texas, and have been pulling. Actually, we just had I don't know, 10 or 15 interns that are all starting right now from various universities. We do have a University of Michigan intern, which is wonderful for me. We've got some UT representation as well here. So any of those Longhorns out there listening, please send your resume. And so we're looking at universities as a variety of universities as good recruiting grounds for us.
Yeah.
And look, in a world where we've been talking about AI at our end users, in our end users' devices, but we're using AI within the company as well. And these younger engineers are quite a bit more fluent in it than the ones that have been with us for a while. And so I like having fresh talent that can come in with new ideas and, who sits down and they're just, coding agent native in the way they are fluent in the way they work, right? So, I had a neighbor the other day asking about whether her high school son, should go take a coding class. And I said, well, I think it's unlikely actually that your son will ever write code in the way that any of us has written code in the past, but he should go take it. He should learn it. And then he should learn how to use an AI agent to do exactly that task, right? So I think it's great. I hope universities are teaching this. We do sense that the younger engineers are all quite a bit more fluent and ready to dive in.
Yeah. No, that's interesting that you say that. I mean, I was actually looking at the data recently because we actually had a live stream from UT San Antonio this morning, actually on our YouTube channel.
Oh, cool.
Talking about neuromorphic computing, speaking of longhorns. But it was interesting to me. And we just went through commencement weekend with our daughter, and everyone's, about trying to get jobs and stuff. Actually in the US, the unemployment rate for recent college graduates, can you guess what the unemployment rate is today for recent college graduates?
I don't want to. I don't even know.
30%, 40%. What do you think the number is?
Are you suggesting it's in the 30-40%?
No, I'm just asking. Do you have a guess?
I have no idea. No idea. Okay. No guess.
So it's only 5.8%.
No kidding. Oh, that's much better than I thought it would be.
No, I'm sorry, 5.6%. I correct myself. 5.6%, which is not too bad since the overall unemployment rate is 3.9%. Last year was actually 5.8%. So it's actually gone down. The unemployment rate for college grads since one year to the next. So it's really interesting when I see that data, and then you see a lot of the kind of catastrophizing about AI is taking everyone's jobs and stuff like that. But like you said, I think people are using AI now natively in how they work, right? Which is different than using AI instead of work, right? And I think that's really kind of where the future is. And I think advice for everybody out there, like you said, is learn how the stuff works, but then learn how you're going to use AI to help, do that stuff as well. And I think that's the right combination. But cool.
What I should say too is that I've seen the bigger companies. I can't speak for these bigger companies who are downsizing because of AI. I'm trying to upsize. I'm trying to use AI to make myself look bigger. I want to look like, instead of a 220 person company, like a 440 person company, right? And then after that, go bigger, right? So I mean, for the moment, it's a fantastic opportunity for us to effectively grow our workforce.
Yeah, no, for sure. And I would say the same here. I mean, we're a small AI startup ourselves, and we have a worldwide footprint. And the only reason we can do that, we just actually passed 100,000 subscribers on YouTube, is because we are using AI platforms to make ourselves look a lot bigger. And I think that's the companies that will be successful, the ones that use AI to, like you said, grow faster and get bigger, as opposed to, hey, I'm going to save some money by laying off some old people and getting AI agents. That doesn't really work. Cool. Well, it sounds like you got your hands full over there with Edge AI, so that's exciting. Indeed. And any sort of parting words of wisdom around? Maybe let's turn it into something, call to action. What's the call to action for those that are listening and are saying, like, this is exciting, this is the future, I want to go do more of this? Like, what should they go do?
I'll say, two things. One is, I think building an Edge AI model these days is a lot easier than you think, right? In that, I got clued into that years ago when we started hiring our first AI engineers. It felt like something where I need to hire a team of PhDs to come build these models and train them and so forth. It's never been easier than it is now. And it will only get easier from here to build these models. So I'd say dive in. There's all kinds of great tools available for that. I'm sure they can come to you guys to learn what all the latest and greatest tools look like. I mean, I know that we've got a number of engineers who just kind of sit there with their desktop gaming PCs and they're training models left and right, and it's great. So don't be afraid of taking that on. Now, the second bit of advice I'll give is do be aware of the resource implications, right? We worry about memory, we worry about performance, we worry about power. You got to pay attention to all those things. And what we're finding at the biggest of companies is there's one group that builds and trains the models, and there's a whole other group that deploys the models on the hardware. And they may not be talking as well as you think, right? And so if you're an AI model, if you're a data scientist, you're an AI model developer, whatever, just be aware of the underlying resource usage. And if you want help in that, come talk to Ambiq, right? We're thinking a lot about how to give our customers tools to do that. It's a hard thing, but at the same time, it's fun for us, right? I think that's about as fun as it gets.
Makes sense. Well, yeah, efficiency is the new currency. That's what they say. So
you got it.
Cool. Well, Scott, thanks again. Thanks for joining us. Hopefully everyone here learned a little something, and we'll talk soon.
Thanks, Pete. Appreciate it.